is that it's not necessarily the case that life remains insignificant on a cosmic scale. Then it may be able to influence larger structures, not just planets and not just solar systems, perhaps not just even galaxies. What if the most powerful quantum processor on Earth just pierced through the boundaries of our reality? In December 2024, Google's latest quantum experiment didn't just break records, it triggered questions no one expected. Did their Willow processor tap into something beneath what we perceive as reality? When Google's quantum AI team announced their results, even their own scientists started talking about parallel universes. Here's what happened. When a chip performs a task in 5 minutes that would take the universe longer than its own lifespan, you have to ask, what is it really doing? The implications are staggering. Google's head of quantum AI publicly stated that their results lend credence to the notion that quantum computation occurs in many parallel universes. But here's where it gets even stranger. Now there's been some confusion swirling around about exactly what Google built. You've probably seen headlines throwing around the number of qubits, but that's where things get interesting. The Willow chip is actually 105 qubits, and the 48 number comes from mixing it up with quantum annealers like D-Wave's machines. These are completely different beasts that work in totally different ways. But here's why this confusion matters more than you might think. When people focus on inflated numbers, they're missing the real story, and the real story is far more mind-bending than any exaggerated headline. Because what Google actually achieved with just 105 qubits is something that challenges everything we thought we knew about the boundaries between our reality and whatever lies beyond it. The difference between hype and reality? Reality is always stranger. And what happened next proves that sometimes the truth is more incredible than fiction. Google's Willow processor achieved something that quantum physicists have been chasing for decades: exponential error correction. This was long believed to be nearly impossible, a holy grail that most experts thought we were years away from reaching. Here's what makes this so incredible: they created a logical qubit that lasted 2.4 times longer than its best physical counterpart. Think of it like this: instead of quantum information degrading faster as you add more components, it actually became more stable. It's like building a house where each additional brick makes the entire structure stronger, not weaker. They did this using something called a surface code with distance 7, spread across 101 physical qubits. For the first time in quantum computing history, adding more qubits actually reduced errors instead of creating more chaos. Willow then performed what's called random circuit sampling in under 5 minutes. To put this in perspective, the world's most powerful classical supercomputers would need 10 squared years to complete the same task. Let me put that number in context for you: that's 10 septillion years. The entire universe has only existed for 13.8 billion years. We're talking about a time span that dwarfs the age of everything that has ever existed by an incomprehensible margin. This isn't just fast, it's so far beyond fast that it breaks our normal understanding of what computation even means. When a machine can solve something in minutes that would outlast the heat death of the universe on our best classical computers, you have to wonder, what's really happening inside that quantum processor? If you find these revelations interesting, don't forget to subscribe. We bring you the latest discoveries you won't hear anywhere else every week. So the power that's hidden in the description of a system like that is immense. And the thing that a quantum computer does is it uses that power, some of that vast computational or configurational power of the thing. Very, very difficult to do, and we've not been able to do it particularly well at the moment. You'll read many papers online where obviously companies like Google, Microsoft, IBM are investing a lot of money in these devices because potentially they can carry out computations that no conceivable classical computer could make within the lifetime of the universe. That's when Hartmut Neven, Google's quantum AI director, made a statement that sent shockwaves through the internet. He said, "Willow's feat lends credence to the notion that quantum computation occurs in many parallel universes." The media erupted. FL Science ran headlines about Google suggesting its quantum computer uses other universes to perform calculations. Futurism and tech blogs across the web seized on the parallel universe narrative, with some claiming Google had basically proven we live in a multiverse. Within hours, the story wasn't just about a breakthrough in quantum computing, it was about the possibility that our reality might be just one layer of something much larger and more complex. Social media exploded with discussions about alternate dimensions, parallel Earths, and the idea that Google's chip was somehow tapping into the computational power of countless other universes. Here's where we need to separate the science from the speculation. The many worlds interpretation has long been a way to visualize quantum superposition. It's one of several ways physicists try to make sense of how quantum mechanics works. When you dig deeper into Nevin's quote, he wasn't actually claiming they'd found evidence of parallel universes. He was invoking the many worlds interpretation metaphorically, as a way to describe the mind-bending scale of what quantum computers can achieve. The scientific community was quick to push back. Ethan Siegel from Big Think called the parallel universe claims absurd hype, writing that quantum computation does not occur in many parallel universes, and that Google's results are completely agnostic about multiverse theories. Physicist Sabine Hossenfelder was equally skeptical, labeling the random circuit sampling task as impressive but impractical, essentially a benchmark designed to be hard for classical computers, but with no real-world applications. So were the critics right? Was this all just overblown marketing speak? Or is there something more mysterious happening when quantum computers push the boundaries of what's computationally possible? So let's address the big question, is there really a hidden layer to reality that Willow somehow accessed? The experimental data says no. There's no evidence suggesting new physics or hidden variables at work. Standard quantum mechanics fully explains every aspect of Willow's behavior, the error correction, the computational speed-up, all of it follows the rules we already know. But here's where things get interesting. Theoretical physicists like Scott Aronson have warned that if hidden variable models of quantum computing actually existed, they would be able to surpass the known limits of quantum mechanics. They could solve problems that even our best quantum theories say should be impossible. So far, there's no sign of this happening. Willow performed exactly as quantum theory predicted it would, just better than anyone expected was possible with current technology. Still, some quantum experiments go further, into the very structure of space-time itself. In 2022, researchers at Caltech used Google's Sycamore quantum processor, a 53-qubit machine, to simulate something that sounds like pure science fiction, a wormhole teleportation protocol. They actually sent quantum information through a simulated wormhole. Quantum magazine called it a quantum gravity experiment on a chip, and for good reason. For the first time, scientists were using quantum computers to probe the deepest mysteries of spacetime itself. While this isn't directly related to Willow, it reveals the path quantum technology is taking, merging computation with fundamental physics in ways we never thought possible. These aren't just faster calcs, they're becoming tools to explore the very fabric of reality. These tabletop experiments can simulate black hole dynamics and test something called the ADS-CFT correspondence, a theoretical framework that suggests our three-dimensional reality might emerge from information encoded on a two-dimensional surface. It's like discovering that everything we perceive as solid and real is actually a hologram projected from somewhere else entirely. There's a fundamental principle in physics called Bell's theorem that rules out local hidden variable theories, essentially proving that there aren't secret mechanisms operating behind the scenes of quantum mechanics that we just haven't discovered yet. No experimental evidence has ever supported the existence of hidden variables in quantum computing. Every test, every measurement, every quantum experiment has confirmed that the strange behavior we see is genuinely quantum, not the result of some deeper hidden reality pulling the strings. Willow followed standard quantum rules with no anomalies. Every qubit behaved exactly as quantum theory predicted, with no mysterious backdoors or unexplained phenomena. But what if it almost broke the rules, and we just didn't notice yet? Let's hear from the scientists themselves. Nevin's parallel universe comment was speculative language, not a scientific conclusion. He was using metaphorical terms to describe something that defies easy explanation, not announcing a breakthrough in our understanding of reality itself. Ethan Siegel was crystal clear in his response: quantum computation does not occur in any parallel universes. He emphasized that Google's results are completely agnostic about multiverse theories, and that the mathematical framework of quantum mechanics doesn't require multiple realities to function. Scientific American covered Willow as a breakthrough in engineering, not metaphysics. They focused on what actually happened, unprecedented error correction that brings us closer to practical quantum computing. The real story here isn't about hidden dimensions or parallel universes. It's about error correction. That's the genuine revolution that could change everything. So what really happened with Google's Willow processor? Let's be clear, Willow did not discover a new dimension or pierce through the fabric of reality. There's no evidence it accessed hidden layers or parallel universes. But here's what's fascinating: it reached a point where imagination intersects with fact. When a chip can solve in minutes what would take classical computers longer than the age of the universe. When it demonstrates error correction that was thought to be nearly impossible. When it pushes the boundaries of what we thought quantum systems could achieve. It's fair to question our assumptions about what's really happening. The line between science and science fiction becomes remarkably thin when you're dealing with technologies that operate at the very edge of physical possibility. Maybe the real hidden layer isn't in some alternate dimension. Maybe it's in the untapped potential of quantum mechanics itself. If you found this discovery fascinating, you won't want to miss our next video. Subscribe and turn on notifications so you're always the first to.